Have you ever wondered how your body can react to something before you even realize it?
Hi,
Let's hear conversation from Professor AKID and his 3 students about this chapter.
Today we'll be learning about spinal reflexes.
Professor, what exactly are spinal reflexes?
Good question. Spinal reflexes are automatic response to stimuli that don't require the brain's involvement. Instead, the signal travels to the spinal cord and back, making the reaction almost instant.
Professor, why do reflexes need the brain?
Because speed is crucial for reflexes. If the signal had to travel to the brain and back, it will take longer. By using the spinal cord, the body can react much faster.
Professor, what kind of reflexes are we testing today?
Today, we'll be testing the knee-jerk reflex, the Achilles reflex, and also measuring reaction times to visual and touch stimuli.
Professor, why do doctors check these reflexes?
Reflex tests help the doctor assess the health of the nervous system. If a reflex is too weak, too strong or absent, it could indicate a neurological issue.
That's really interesting. But how do we start the experiments?
Great enthusiasm. Let's begin by testing the knee-jerk reflex. Grab a reflex hammer and I'll show you how it's done.
Now we're going to conduct experiment 5.1, patellar reflex, which is knee jerk, that will be demonstrated by MIOR and HIDANAH. In the first trial, the subject demonstrated a sharp leg extension upon striking the tendon, showing the reflex arc typical function. In the second trial, while breathing, the reflex may exhibit a slight reduction in intensity due to divided attention, but it typically remains strong since reflexes are involuntary. Lastly, in the final trial, despite the subject's attempt to suppress the reflex, the knee jerk are often persist. This outcome highlights that reflexes bypass conscious control and are managed by spinal cord's neutral pathway.
Next, we will proceed for experiment 5.2, which is Achilles reflex, also known as ankle jerk, and it will be demonstrated by these guys. When the Achilles tendon is slightly tapped, the foot demonstrates a quick downward movement, indicating the normal functioning of the reflex arc. If the tapping is repeated at approximately 2 taps per second, the response may reduce slightly due to reflex fatigue.
First trial, the subject finds it difficult to swallow saliva a second time immediately after the first swallow due to temporary reflex inhibition. After drinking water, the subject can easily perform successive swallow without difficulty. This demonstrates the hydration facilitates the swallowing reflex.
So next for the experiment 5.4, which is reaction time to light. So for this experiment, DANISHA will be the experimenter and HIDANAH will be the subject.
The time lapse recorded between the experimenters and subject stopwatches shows the subject's reaction time to visual stimuli. After 10 trials, the difference reaction time between the experimenter and subject is calculated. This reveals how quickly the subject responds to a visual cue, with variability depending on attention and practice.
Now we will proceed to the next experiment, which is reaction time to touch. So this will be the material needed. First of all, 2 hand stopwatches. Second, we need ruler. And lastly, we need thread. reaction time should be in the range of 0.15 to 0.3 seconds for an average adult. Trained individuals such as athletes may have shorter reaction times, while those with slower reflex may have time above 0.3 seconds.
Next, we are going to proceed to our discussion of the experiment. So for the first experiment, we tested the human patellar reflex, also known as the knee-jerk reaction. We conducted 3 trials under different conditions to see if factors like conscious resistance or distraction, such as reading, would affect the reflex. Our results showed that the knee-jerk reactions remain involuntary and consistent, regardless of the subject's attempt to suppress it or their level of focus. This is because the patellar reflex is a spinal reflex, meaning it occurs automatically at the spinal cord level and it does not require the input from the brain.
In our second experiment, we tested the Achilles reflex, also known as the ankle jerk reaction, by tapping the subject's Achilles tendon while their foot was relaxed. Our results showed that they automatically jerked forward every time, even when the tapping was repeated quickly. This confirmed that the Achilles reflex is involuntary and consistent, as it is controlled by the spinal cord and doesn't need the brain's involvement. In our third experiment, we tested the swallowing reflex by having the subject swallow once and then try to swallow again immediately. Our results show that the first swallow happened easily, but the second swallow was much harder to do without a break. However, when the subject drank water, the swallowing became easier again. This suggests that the swallowing reflex needs a brief reset period and is influenced by muscle coordination, unlike spinal reflexes, which happen instantly and repeatedly without hesitation.
So we move on to the fourth experiment. In our fourth experiment, we tested reaction time to sight by measuring how quickly the subject would stop a stopwatch after seeing the experimenter stop theirs. As I remember, the subject was me and the experimenter was DANISHA. Our results showed that the reaction time varied across trials, with some responses being faster than others. Unlike spinal reflexes, which happen automatically, this reaction requires the brain to process visual information before responding, making it slower and less consistent than reflexes controlled at the spinal cord level. For the last experiment, which is our fifth experiment, we tested reaction time to touch by having the subject close their eyes while the experimenter stepped on their foot, measuring how quickly they could stop a stopwatch in response. Our results showed that the reaction time was still delayed and varied between trials, similar to the sight reaction test. However, in some cases, the subject reacted slightly faster to touch than to sight, suggesting that tactile stimuli may be processed more quickly than visual ones. The inconsistency in response time highlights that this reaction required brain processing rather than an automatic spinal reflex, making it slower and less predictable compared to reflexive action like the knee-jerk or Achilles reflex.
Okay, so I think that's the end of today's discussion. Do you guys agree?
Yes!
After completing all the experiments and discussing our finding, we understood reflex signal flow. Here's a video of us demonstrating it.
Oh no, Adam has said something hard.
Emergency! Integration CNS, please do something. What happened? Let me process this. OMG, code red. I will send signal to motor neuron.
Receive, I will activation motor neuron now. Muscle, pull back the hand now.
In conclusion, this experiment demonstrated the role of spinal reflexes in human physiology, specifically the patellar reflex. The results confirm that reflex actions are involuntary and occur without the direct involvement of the brain, highlighting the efficiency of the spinal cord in processing stimuli.
Additionally, reaction time measurement showed that external factors such as fatigue, practice, and individual differences influence neural response speed. Understanding these reflexes is crucial in diagnosing neurological conditions and assessing motor nerve function.